સ્કૂલ ઓફ સાયન્સ બામણમાં ઓનલાઈન અભ્યાસ રસાયણ વિજ્ઞાન લેસન 2 દ્રાવણમાં તમારું હાર્દિક સ્વાગત છે. સ્કૂલ દિવસે દિવસે પહેલાં ઝલક જોઈશું અને સૌથી પહેલાં જોરદાર રિઝલ્ટ વિશે તમે વિચારી શકો છો કે આપણા મજાનું રિઝલ્ટ અહીંયા તૈયાર છે. ઓકે, ત્યાર પછી આપણી સ્કૂલમાં ધાર્મિક કુમારને, મિત કુમારને, હિમાક્ષીને, સીબેનને શું મળ્યા છે? સ્કોલરશિપ સર્ટિફિકેટો મળ્યા છે. અને એ જ રીતે આપણું આ ધોરણ 12નું પરિણામ તમે જોઈ શકો છો. તો એવી જ તમારા પાસે પણ અપેક્ષા સાથે આપણે વેલકમ બેક dear students to Lux School of Science Bamanwa, and here lesson number 1 is with heading solid state and lecture number 3. So today we are going to talk about interesting topic about solids, and that is now on that day, yes, previous video here you have studied about the crystalline and non-crystalline substance. Now today you are going to study about another thing, other solids. Besides crystalline and amorphous solids, there are some solids which apparently appear amorphous but have microcrystalline structures. See, some solids are there which are seems to be non-crystal, non-crystal, that means the amorphous substance, that means they are substance, but though they are amorphous, they look like crystalline structure at micro level. That's why we can say that microcrystalline substance. So hope that you understand this topic, what we are going to do today about this crystalline and non-crystalline structure, about the another world of the crystals, solids which are actually in between the amorphous and crystalline. These are called as polycrystalline substance or polycrystalline solids. So now today the polycrystalline solid is our new topic, and metals often occurs in polycrystalline condition. Individual crystals are randomly oriented, so metallic sample may appear to be isotropic even though a single crystal is anisotropic. So here metal will behave like this, because see, initially when we were talking about the amorphous and crystalline substance, then I talk about the isotropic nature and anisotropic nature. At that time you might be confused. Okay, actually crystalline substance should be isotropic and non-crystalline substance should be anisotropic, but ત્યાં ઉલટું હતું કે crystalline structure હતા એ એનાઇસોટ્રોપિક હતા અને એમોર્ફિયસ સબસ્ટન્સ આઇસોટ્રોપિક. પછી તમારા મનમાં ક્વેશ્ચન આવ્યો હશે કે આ મેટલ ને બધાનો તો રિફ્રેક્ટિવ ઇન્ડેક્સ અને આ બધું તો સેમ જ હોય. તો ત્યારે આપણને ખબર પડી કે ના, આ લોકો એકચ્યુઅલી એમોર્ફિયસ સબસ્ટન્સ છે પણ માઇક્રો લેવલ પર ક્રિસ્ટલાઇન્સ છે. એટલે એની પર્સનાલિટી એમોર્ફિયસ હોવાથી એ લોકો મેટલ જેવા જે સબસ્ટન્સ છે એ લોકોનો નાનો ક્રિસ્ટલ એનઆઇસોટ્રોપિક છે પણ આખા impact any isotropic પડે છે. So this is the topic you can understand. This is the topic you can understand. So here interesting topic, polycrystalline solids. So I hope that કે તમને slightly confusion હતું, એ મનમાં રહેલું confusion, I think so it is resolved. Amorphous solids are useful materials. Glass, rubber and plastics find many applications in our daily lives. Amorphous silicon is one of the best photovoltaic material available for the conversion sunlight into electricity. So not only this thing, actually we can say that amorphous solids are very useful in our life. So how amorphous solids are useful? So amorphous solids are useful in the matter of they can be used in our daily life, and actually out of that silicon is more important than any other thing. So hope that you understand these points of uses. Okay, so other solids and its applications is a thing. Now we are going to change the topic, and this is very vital, interesting, and slightly innovative for you. है ना? Come on, let's check what it says. Intake questions 1. Why are solid rigids? Solids are rigid because they are in regular shape, okay, in very near, and their kinetic energy is very less due to the less heat energy, and that's why they only vibrate. They vibrate from its mean positions and don't move, so that's why they are known as rigid material. Why do solids have definite volume? It is also an interesting question. So solids are having intermolecular attraction force, and due to that there is no space in between them, so they are very closed pack, and as they are closed they are able to form definite volume. Okay, so that is the second point. Third point, classifying as amorphous or crystalline solids: polyurethane, then naphthalene, benzoic acid, teflon, potassium nitrate, polyvinyl chloride, fiberglass, copper. So here I will underline two things. Rest of thing you will understand. मैं આ બે ને જુદા લખું છું, બરાબર? તો બાકીનું તમે વિચારી લો કે શું હશે. હા, એ છે હજુ. આ ત્રણ જુદા છે, બાકીના બધા સરખા છે. એ આપવાનો. You will find out crystalline and amorphous. પોટેશિયમ નાઇટ્રેટ છે, ખબર પડી જ જવી જોઈએ. ઓકે. Refractive index solid is observed to have the same value along all direction. Comment on the nature of the solids. Would it show cleavage property? Same value in direction, all directions. Amorphous do not have cleavage property. Okay, so these questions are completed. Now hope that you will write these 4 questions as a assignment. Okay, so now we are in that another world. Classification of crystalline solids. We can classify the crystalline solids. This will be the not only understand, this will be the heart of the. In section 1.2 we have, and that they have only short range order. However, are crystalline in nature. For example, all the metallic elements and silver, non-metallic elements like, and compounds like sodium chloride, zinc sulfate, and naphthalene crystalline solid. So this is the wide range, and due to its wide range we think about the crystalline solid will move and in which way they will behave. Here is the interesting topic about the crystalline. So this will give you idea to check out this. Metallic elements like iron, copper and silver. Non-metallic elements like sulfur, phosphorus and iodine. Compounds like sodium chloride, zinc sulfide and naphthalene from crystalline solid. So in previous case you will go learn, check out what is the answer will be the there. Crystalline solids can be classified in various ways. The method depends on the purpose in hand. Here we will classify crystalline solids on the basis of nature of intermolecular forces or bonds that hold constituted particles together. So crystalline solids can be defined as the regular arrangement, and due to that regular arrangement, here we can say that intermolecular between the solid constituted particles, how are they? These attraction force. Dear students, actually, if we talk about attraction force, then these four attraction force are very famous. Van der Waal attraction force, okay, ionic bonds attraction force, attraction force, and metallic bonds attraction force. And due to that reason, we can classify crystalline substances into the four category which are having van der Waals attraction force, covalent, and metallic. According to that, molecular solid, ionic solid, metallic solid, and covalent solid. So let's learn now about this. Okay, which are these categories? Going to study is molecular solid. So moleculars are the constituent particles of solid. अगर એના અંદરના જો constituent particles શું છે ભાઈ molecules છે, then we are studying about the particle as a molecules, then we can say it is molecular. Further subdivided into following categories. Actually these molecules, and they consist of slightly four in them. Okay, now attraction, which several categories are there, so that okay, so these several categories: London type force, there in van der Waals attraction force, the London force is there. Then dipolar force are there, hydrogen bond force are there. So such forces are there, and according to that this will behave. So that's why we can talk about the solids in different way. So there are further substances divided into following ways, which these ways are: first one is non-polar molecular solid. They comprise either atoms, for example argon and helium, molecules formed by non-polar covalent bonds, for example H2Cl2 and I2. In these solids, the atoms or molecules are held by weak dispersion forces or London forces, about which you have learned in 11th. ચલો જરાક ધ્યાન રાખજો કે અગર આપણે એટમ કમ્પાઇલની વાત કરીએ તો એટમ કમ્પાઇન્ડ આર્ગોન હિલિયમમાં થવાનું છે. શામાં થવાનું છે? આર્ગોન અને હિલિયમમાં. મોલેક્યુલર કમ્પાઇલ કોનામાં થવાનું છે? તો આયોડિન, ક્લોરિન અને હાઇડ્રોજનમાં થવાનું છે. તો આ આપણે સમજી શકીએ છીએ કે કોના અંદર કયા ટાઈપના મોલેક્યુલ. એકચ્યુઅલી હાઇડ્રોજન ગેસ, ક્લોરિન ગેસ કે આયોડિન ગેસ, these are bimolecular, or argon and helium gas છે એ બાયમોલેક્યુલ્સ નથી. બધા પહેલો ક્વેશ્ચન તમારા માઇન્ડમાં આવવો જોઈએ, સર યાર we are talking about a solid and you are here putting the idea about the gas. What do you think? Is it so? But in previous lecture and also on board I have explained you, dear students, remember this: any object of the world, whether it is in BC form, whether it is in plasma form, whether it is in liquid form, or whether it is in gaseous form, by certain temperature and by certain pressure, they can be converted into solids. At high pressure and temperature. Similarly, sometimes low temperature and low pressure will to manage any material convert into solid. So I don't think you have some problem. You must remember this. So here we are talking about that solid after conversion solid, they will behave as a molecular solid. In these solids, we are starting from here. In these solids, the atoms or molecules are held by weak dispersion forces like London forces, about which you have learned in 11th standard. These solids are soft non-conductor of electricity. So actually these solids are soft, and if it go with its conductivity, they are non-conductivity or as well heat. Their boiling point will or their melting point will be low, and as their melting point is low, they are at room temperature behave as a gas. That is simple thing. આમ તો એ સોલિડ જ છે, પરંતુ એમના મેલ્ટિંગ પોઈન્ટ લો છે, અને ડ્યુ ટુ ધેટ મેલ્ટિંગ પોઈન્ટ લો હોવાના કારણે at room temp they are behaving as gas. So are usually in liquid or gaseous state at room temperature and pressure. Totally understanding of the molecular solid which rise in molecular solids. So this first portion is completed, written in second portion. Polar and hydrogen bonded solid. Polar molecular solid. The of substance like HCl, SO2, etc. are formed by polar bonds. The molecules of substances like HCl, SO2, હવે HCl પ્લસ અને Cl માઇનસ પોલાર થઈ ગયું. S ની અંદર સ્ટ્રક્ચર જોજો S નું. HCl તો તું અન્ડરસ્ટેન્ડિંગ કરવા માટે એકદમ સિમ્પલ છે કે ભાઈ એક બાજુ H છે, પછી ડેશ 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 છે. ઓકે, હવે આ H અને આ પોઝિટિવ છે અને આ છે, બંને એકબીજાને એટ્રેક્ટ કરશે. સો ધેટ્સ વાય ધીસ બોન્ડ વિલ બી ધ પોલાર બોન્ડ. આ બોન્ડ પોલાર બોન્ડ, that is the simple idea. But when we talk about sulfur dioxide, how to see the structure of the sulfur dioxide? Interesting structure. કે અહીંયા સલ્ફર છે, ઓકે, ત્યાં તો પેલું લખાયેલું આવશે, અહીંયા લઈ લઈએ. અહીંયા સલ્ફર છે, એક બાજુ ઓક્સિજન છે અને બીજી બાજુ પણ ઓક્સિજન છે, બંને બાજુ ઓક્સિજન છે. But what is the difference between these two oxygens? So these dear students, એક બાજુ ડબલ બોન્ડ હશે બંને વચ્ચે અને એક બાજુ બંને વચ્ચે બોન્ડ હશે. ઓકે, તો ડબલ બોન્ડ અને સિંગલ બોન્ડ છે, તો તે થોડુંક તમને પોલાર સિચ્યુએશન આપે છે. ઓકે, you got the idea. So HCl and SO2 are formed by polar covalent bonds. The molecular in such solids are held together by relatively stronger dipole-dipole interaction. So previous case, London force. Now here, dipole-dipole interaction. Also you have studied in 11th standard. These solids are soft and non-conductors of electricity. Though they are contained positive, negative like a polar thing, but as there is no free electron or any ion formation, as simple state, they are non-conductor of electricity. Their melting points are higher than those of non-polar molecules, but the dipole-dipole interaction force is slightly higher than that of the London force. That's why these solids are slightly more attractive, as that's why their melting points are slightly higher than those of the non-polar molecular solid. Yes, most of these are gases or liquids under the room temperature and pressure. એટલા માટે મોટાભાગના આ સોલિડ્સો જે છે એ રૂમ ટેમ્પરેચર પર તો લિક્વિડ છે ક્યાં તો ગેસ છે. સોલિડ SO2 and solid ammonia are some example of such solids. So આ બધા પણ સોલિડ હોય છે અને so very beautiful solids they are look like when you will see such sulfur dioxide નો આઈસ ઓસલા જોશો ને ice cube of the sulfur dioxide, beautiful, slightly green colors, very delightful. ખાવાનું નથી. So dear students, hydrogen bonded molecular solid we will study in next video. Okay.